Nishk, I'm from Team Maverick. This presentation gives you an overview on how we proceed on our project and what our project actually does. So let's begin with the presentation stages. Where in stage 1 we'll be building up the rover platform. As you can see, it is mentioned detailedly in the roadmap. In the stage 2, what we'll be doing is we'll be setting up the GPU based object detection using Jetson Nano, and also we'll be providing it with the vision system along with the indoor navigation system where we'll be using a lidar. This is the exact image of our rover that we have built using the DIY kit, which is provided with 6 wheels, 2 chisels and 6 suspensions. We've also used an aluminium sheet and we've molded it so that it can sustain some good weight, as well as the design looks good. This is how our rover looks after we fix the aluminium sheet on top of it. We've also built a small space for the battery at the back, and the components will be inside except for the robotic arm, which will be placed at the top. The next part is Pixoc. We use the Pixoc. The reason why we chose the Pixoc is because the Pixoc is the flight controller that controls the rover. The reason why we chose it is because it has advanced sensor technology, as it includes 3-axis accelerometer, 3-axis gyroscope, 3-axis magnetometer and a barometer. It also has multiple connective options, so that's the reason why we choose this. The next, we use a saber-tooth. The saber-tooth model that we use is a 2x12 amps. The reason why we chose this is it can control 2 motors at a time, and the motors we are using are 6 in number. We'll be connecting the left side 3 motors to one output and the right side 3 motors to the other output. So the ideology on which saber-tooth works is it sends the signals to the motors when the user or when the command is passed to the saber-tooth. Next, a telemeter is a wireless communication model through which the robot will be available to communicate with the computer. So the reason why we use telemeter is that there is no need to contain a wire in between the computer and the robot. Next is the GPS module. The GPS module is used to know the location of the rover as well as to move the rover to a desired point. For example, if a person wants to move the rover or the robot to a particular point which is based on the GPS, we can just give the point's location to the rover and it will be directed to that point automatically by using the GPS module, which also has a compass. Next, Jetson Nano. Jetson Nano is a small computer design which acts like a companion computer when the rover is in motion. So the programming part and the containing all the information will be done through Jetson Nano. So basically we can say that it acts like a brain for the robot. We also use Mavros and ROS programming to control the rover. The Mavros will be done inside the Jetson. Once the program is written, will be running in through Jetson. So the Jetson is the brain for the robot. Next, this is the video that demonstrates the movement. This is the video that demonstrates the movement of the rover, which is moving in a squared path. We have done the programming of the rover using the drone kit and Python programming. Next, this is the video that shows about the assembly of the robotic arm. This is us assembling the robotic arm. The robotic arm we are supplied with is a 6 DRF, which implies it has 6 degrees of freedom. The reason why it has 6 degrees of freedom is because it consists of 6 servo motors. So each servo motor is provided with a degree of freedom. Next, this is our robotic arm, the black one at the top of the rover. This is the complete picture after integrating the robotic arm on the rover. Next, this is the rover at the last. This is how it looks. And now we are at the end of the stage 1. We are gonna start the stage 2.